to Waste Management McDonough Sustainable Innovation Collaborative, the shortest company name in the business. Larry's a consultant, an entrepreneur, and a business leader who's worked across a wide range of industries, including retail, environmental, waste and recycling, energy, manufacturing, and commercial real estate. In addition to his role at McDonough Innovation, he advises governments and Fortune 1000 companies on how to create effective waste and recycling strategies, and a graduate of Arizona State University. So please welcome Larry Black.
Thank you, Robert. We are a room full of dreamers. We are a room full of inventors. We are a room full of people with big ideas and big ambitions for solving the world's problems. Unfortunately, that's not the reality of recycling in America. A little insight into that. Most recycling and waste contracts let in the United States are for a period of a minimum of 10 years and sometimes as much as 30. And what that essentially means is at the start of a contract, you have a certain set of conditions in place, and it is not incumbent upon the waste handler or the recycler to change those sets of conditions, change the mechanisms, change the equipment, change the technology over the entire 10 to 20-year life cycle of that contract. So where we may have a lot of dreams, and we've seen incredible things that can be done and are being done, there are significant barriers, especially in the United States, to achieving those because of a contract basis on which waste and recycling is managed in our country. That being said, I'd like to take you on a short journey that encompasses much of what has been discussed today and gives it a little different spin. When we say that design is so important, Mr. McDonough, who is really the founder of the circular economy, the creator of Cradle to Cradle, if you've read his book, Cradle to Cradle, he started this whole movement of the using material again and again. And his philosophy was that design is the first signal of human intention. What do we intend when we actually design something? And I don't think we've intended what the result has been. We have a world that is in a really sad shape. I think we all know that. We all appreciate it. We all want to do something about it. You know, behind that is a very fundamental equation. We have moved from a society that had a number of, or a willingness to go the extra mile. Now we're a society that is very surrounded around convenience, and that convenience is killing us. Packaging things to make it easier to buy, easier to sell, easier to keep refrigerated. Everything that we do for the sake of convenience is usually multiplying the packaging factor by a 2 to 5 and sometimes a 10x factor. It is a very significant element that convenience is such a relevant part of this current recycling challenge. I like this tree. I don't know if you could see this as a tree. This is a tree in the Republic of Georgia. It is covered with the most convenient thing in the world, the little plastic shopping bag. And obviously the tree is pretty much on its way to dying. And if you go to the Republic of Georgia, which once used to be an absolutely beautiful place, you will now see tree after tree, bush after bush, parts of the landscape that look like this. And one of the interesting things when you talk about barriers and realities of recycling is when the Russians occupied the Republic of Georgia, everybody shopped with a reusable bag. There were no such thing as plastic bags. They were actually, the stores couldn't afford them, the country couldn't have them. And so what happens? The moment the Russians leave, the Georgians think that the true sign of Western civilization is the disposable plastic shopping bag. And every store goes to plastic disposable shopping bags as quickly as possible, because that is the new status symbol, is that you don't have that Russian era take along homemade bag to put your groceries in. If we think about it, and it'd be nice if we did have more designers in the room. I know there was a show of hands earlier, and it was a fairly small group. In thinking about the objectives for design, one of the ones that's often left out, and although we saw it in the presentation earlier, was the idea of retaining it. Recycling is a real challenge, as in reducing the actual usage of plastic. But if we began to think about retaining, which is basically using the same plastic container for multiple uses, it would be quite possible to make a good dent in that mound of plastic that we are looking at on a global basis. Because we certainly are really eager to eliminate the take, make, waste equation. But what follows that? What else can we do? Some of the key design elements, I think we heard a wonderful presentation on materials. I'd like to just talk about shape and size for a moment. We did at Waste Management, we did a consulting project with a large CPG firm. And they asked us to analyze 75 of their products, which were listed as being recyclable. They were also designated for a new program about recycling in the bathroom. And they wanted us just to basically confirm the recyclability of these products. Well, we looked at all 75 of them, and we put them through a traditional MRF, or material recovering facility, here in the United States. We put them through 5 different MRFs, and the result was, out of the 75, only 3 could be recycled. And that was quite shocking to this firm, that they had truly believed that they had created a number of recycled packages, and yet, in the end of the day, only 3 out of 75 could. And the reason for that was basically size and shape. I think, as you saw earlier, if something is too small, it can't be recycled. And what's too small? Well, oftentimes it's 4 inches or less in length. The sorting machines just can't see it, or it gets sorted out prior to even getting to the sorting machines. It goes through what's known as a white mesh net, and if something is smaller than the groove or the holes in the mesh, the material falls through it. And then the shape. One of the things that a lot of bottles are round, and what happens with a round bottle in many sorting facilities, not some of the ones you've seen today, but the ones that exist in most places in the United States, when a round bottle is going down the recycling track, the machines can't sense it because of its movement, and they don't know what it is. So if in doubt, throw it out. It goes into the landfill bin. And so one of the reasons so many of the products that were disqualified as being recyclable in reality were disqualified because they were in round cylindrical containers, and the scanning machines just flat couldn't see them. The other problem is that many people will take, because they want to save space, they want to crunch like a plastic water bottle or a plastic milk carton or that. Well, when you go and crunch that, the typical sorting machine and the typical scanning machine doesn't know what it is now. And so it throws it away. And so while we're trying to save space and we think it's a good idea, it unfortunately renders a very good bottle unrecyclable. And then the last piece is deconstruction. And what that essentially means is, for more complex objects, can you take it apart and reuse and recycle the pieces? A classic example for Mr. McDonough was the original Herman Miller Arion chair. When they first built it, it was not recyclable. It had recyclable material, but it was very difficult to take it apart. And one of the early projects that Mr. McDonough undertook was to redesign that chair in a manner that each part could be taken, literally taken apart easily. And it got down to, when it started, it had 18 different screws, and they got it down to 3 different screws. And it could be taken apart, and then each individual part could be recycled, whether it was aluminum, whether it was plastic, whether it was steel. These parts could then be recycled. So one of the things to consider in the whole subject of recycling is when you're making more complex products, like a car or a chair or some appliance, can it be taken apart easily and then those parts be usable in a recycled situation? One of the biggest challenges in recycling is creating demand. Nothing happens in recycling unless somebody's willing to buy it at a price that somebody's willing to put the effort in to collecting it, aggregating it, and offering it for sale. And one of the biggest challenges over the past few years with the low prices of oil has been that plastic is so inexpensive that the recycling is just not a profitable venture. And the situation with that is it's priced on a daily basis. If you want to sell plastic today, it will be one price. If you sell it next week, it's another price. Next month, another price. It is a true commodity play. Very seldom will plastic have a stationary price for a very long period of time. It moves with supply and demand. It also moves geographically. The price for plastic offered in a town in the Midwest, because to take it really to a facility is difficult, may be much lower than a price offered where a recycling facility is nearby. So across the country, you will have many different prices for each grade of plastic, depending on demand, logistics, and the current marketplace. What this does is it really creates great uncertainty, and that's why many companies are unwilling or unable to invest in the newer technologies because of the uncertainty of market demand. When we talk about recycling, there's several critical elements. Design, certainly, demand, which we've talked about, but the last one is collection. One of the things that we've used often is the word recycling for what is really collection. Oftentimes we think of, well, if it's off the beach, it's recycled. If it's out of the event venue, it's recycled. If it's put in some recycling bin, it's recycled. Well, that's only the first step on the journey. There's many steps in between. And depending on the cities, one notable example I'll call out is Houston. Houston used to have, for Texas, a reasonable recycling rate. But the city of Houston decided they were going to move from separated collection to single stream, because they felt that would, as many cities do, increase the recycling rate. Well, in the practical reality, it doesn't. It actually decreases it significantly. And the reason for that is before, when you recycled and you separated, the material didn't get contaminated. What happens when you dump it all in one bin is the material becomes contaminated. And so Houston will tell you that they recycle a very large amount of material. False. They collect a lot of recyclable material. At the end of the day, if they collect 75% of recycled material at the front end of a MRF, about 25% comes out the back end, and 50% goes to the landfill because of contamination. So one of the things that often we have, especially in this country, is a confusion between collection, recycling, and actually something being recycled. There are three parts to that equation. One of the other challenges that we find when we go out to think about using recycled plastic is designers and engineers, many of them, do not want to use recycled plastic. They don't want to use a plastic that they don't know its origin, its complexity, what's in it, its properties. And so the automotive industry is actually one of the ones, as you've seen, that's done yeoman's work at accepting and teaching their designers and engineers. But across wide swaths of the manufacturing community, if you talk about recycled plastic, forget about the cost. It's the variability of the material, the uncertainty of the material that really drives designers and engineers crazy and makes them just spec virgin plastic. I mentioned earlier on William McDonough, and for those of you who have not read the book Cradle to Cradle or The Upcycle, those are really, Cradle to Cradle was the book that really kicked off the entire concept of circular economy. Mr. McDonough is both an architect, a thought leader. He was named Times Hero of the Planet. He serves on a number of advisory committees. And his really has driven this whole conversation over the last 25 plus years. And one of the things he's very proud of is the Cradle to Cradle Products Innovation Institute. Because a lot of times designers and people who make things have no idea where to go to understand recycling, to understand reuse, to understand how do you make something, how do you design something that in fact can be recycled, can be upcycled, can have use after use after use. And one of the great places to drive these folks is the Cradle to Cradle Products Institute. And they've done tremendous work in packaging. They've done work in across a wide range of products very successfully with many major brands, and they stand there ready to help brands convert from wherever they are on the cycle of innovation to really becoming quite imaginative in how they create, design their products for being recycled and reused endlessly. Because at the bottom of their philosophy is they eliminate the concept of waste. You know, if you think in the natural world, there is no such thing as waste. And if we think in our world of trying to eliminate the entire concept of waste, we become very focused on what could be possible. And you've seen it in presentation after presentation today about eliminating the concept of waste. Dean Kamen was an inventor. One of the things he invented was the Segway, the little scooter. He invented some water purification things, but one of his favorite topics was, don't tell me it's impossible, tell me you can't do it. And in a room like this, we're a room full of people who say, I can do it, I can figure this out. But I could tell you in general, when it comes to the world of recycling, most people talk about, I can't do it, or better yet, it's impossible. And one of those impossibilities was turning plastic and plastic residue into oil or some usable material. I know we have somebody here from MBA Polymers. There are some companies out there, some remarkable innovators who have discovered and actually built feasible plants, MBA Polymers is mainly in Europe, that can convert plastic materials, all sorts of plastic residue into a usable plastic pellets. That can be done, and it can be done at a commercially viable basis. One of the holy grails of plastic recycling was turning plastic into oil, especially when oil was $100 a barrel. And to that end, I could tell you that the waste industry, just the big 3 waste companies, invested over $100 million in trying to figure out how to convert plastic into oil. They might as well have burned the $100 million. There was no successful projects at anywhere close to commercial scale or anywhere close to really approaching that $100 a barrel. And part of it was complexity. And a little company in Akron, Ohio decided to go simple and said, we're going to take a bunch of off-the-shelf products, put them together in a factory that only costs about 20 million bucks, and see if we can't convert plastic into oil for less than $40 or less a barrel. And they've done that. As a matter of fact, in August, they had trucks that drove up, filled up with oil produced from plastic that cost around $40 a barrel to manufacture. So these are two examples of technology. We've seen a lot of technology today that in fact can take this overriding plastic problem of what do we do with plastic and convert it into a viable solutions. As I said, we're a very innovative group. We're a group that wants to dream and a group that wants to find solutions. Conferences like this go a long way toward that, but I will tell you, the biggest barrier we face in this country to recycling at an effective level is the actual waste management system that's in place, which has little or no incentive to really embrace new technology or to embrace new forms and new ways of doing business. Thank you.